Hello everyone, welcome to Helm of Science. So we have just one more set of joint entrance examinations that are pending in the month of September or mid of September. I hope it will take place. So our preparation strategy should be just revision and practicing more and more of questions from the previous examinations or the last 10 years questions of the joint entrance examinations. Owing to that, we have solved many such series regarding bonding, coordination chemistry, solid state, atomic structure, periodic table, etc. Today's topic of discussion will be one such topic which is undervalued in terms of importance, uh, more so because students find it very tough, and some of the students also do not give that much of importance to the chapter and kind of ignored it. But then, if you see the recent year question papers, like 2019 or 2016-17, these papers, they have started including questions from this chapter. So we have to have a, if not very good knowledge, but a sound knowledge of the topic, at least of the important formulas that can be used in the questions, and the approach to the questions should be known to us so that we can solve the questions, if at all it comes in the exam, successfully. So without wasting much time, let us just get into the chapter. The chapter is States of Matter. States of Matter. This was a chapter that was there in the syllabus of your higher secondary examination in class 11. Uh, so we'll be discussing questions related to that. The first question says, it's a graph mentioned basically. So let me just draw the graph. It shows a distribution function and it is plotted against speed of molecules. And you have three graphs which go like that. Okay. So the question is that there are three gases mentioned: hydrogen, nitrogen, and oxygen. So which graph corresponds to which of the gas is the question. This is point 1, point 2, and point 3. So 1, 2, 3 represents which gas is our question. So how do we do it? See, whenever the word speed is mentioned, we will always try to use the most probable speed of the gases. Why? Because this kind of graph, that is the graph of distribution function versus speed, refers to the most probable speed. So most probable speed has the formula equal to root over of 2RT by F. Now R is a constant, the value 2 is a constant. So effectively it is proportional to root over of T by M, right? So for hydrogen, the temperature is mentioned as 300 Kelvin and mass would be 2. So it is root over of 150. Nitrogen is root over of temperature is 300 divided by 14 into 2, 28 is the mass. So this should be root over of 10.7. And oxygen is temperature is 400 as mentioned, and the mass is 32, 16 into 2. So this is 12.5 square root. So you don't have to solve the square root value. Just see the value of root over of 150 will be definitely higher than these two. So obviously this should be the highest value. So highest value as per the graph would be this one, 1. So 1 would be hydrogen. Then coming to 2 would be oxygen and 3 would be nitrogen. This should be my correct answer. So this corresponds to so 1 should come out to be hydrogen, 2 should come out to be oxygen, and 3 should come out to be nitrogen. Now you might mark this answer, but this will be wrong. Why? Because one thing, see, we have analyzed what? We have analyzed the speed, right? So the value of speed should be highest. Now which coordinate depicts your speed? The x-axis. So the x-axis, if it is depicting the speed, then the value of speed is highest in which one? Number 3. So hydrogen should be number 3. Then oxygen should be number 2. And nitrogen should be number 1. This should be my correct sequence, which matches option number C of your answer. So the approach of the question is important, how we are dealing with the question, right? Now, moving on to the next question. The next question gives us certain values of A, B, C, D, which I need to write before proceeding with the question. And you have the values for A and B. 642, let's just take roughly 155, 431 and 155. Another 0.43, 0.05, 0.04 and 0.05. Okay, first things first, what does the small alphabets A and B denote? Now okay, first of all, where do we get the A and B from? From the real gas equation, which is P plus A by B square. I'm considering 1 mole, okay, and I'm removing that term from the equation. This is the equation, right? So in this case, A is what? A actually denotes the intermolecular force of attraction between particles. Intermolecular force of attraction. And what does B denote? It denotes any volume correction. Right? So, how can we compare? See, for A and C, the value of B is same. Right? So, we cannot compare that way. So, we have to compare on the basis of the value of A. Now, A shows intermolecular force of attraction, right? So, greater the value of A means greater the intermolecular force of attraction. Now, if intermolecular force of attraction is greater, then what happens? Then the molecules are closely packed, so the volume occupied will be less. So, we can say if A directly refers to the intermolecular force of attraction, so the molecules will be tightly packed, hence they will occupy lower volume. So we can say the value of A is inversely proportional to volume occupied. So in this case, the one having the lower value of A should have a greater volume. So C should be having a greater volume than A. That is one conclusion we can jump to. So first check the options. See, in option number A, it says gas C occupies lesser volume than A, which is wrong. So A gets automatically removed. All the 3 other options says that C occupies more volume than A. So that's fine. Now coming back to B and D, which has a same value of A, comparing B. Now B is volume correction. So greater the value of B, greater will be the volume occupied. So in this case, the value of B for gas D is greater than that of gas B. So D will have a greater volume than gas B. So that option will match with option number C. Right? So that's the answer. Moving on to the next question. So you can see that these are just basic concepts from the chapter. Nothing nothing related to detailed calculations or sums or anything like that. It's just very simple basic concepts. Okay. Question number 3 says that there are 4 noble gases: neon, argon, xenon and krypton. and they are supposedly behaving according to the gas equation mentioned is P equal to RT by V minus B. And the question is, which gas will have the steepest plot or steepest increase in the plot of Z versus P? Fair enough. So first we have to find out the Z from this equation. How to do? Multiplying this side, so PV minus PB equal to RT. Dividing by RT on both sides. So PV by RT minus PV by RT equal to 1. So PV by RT equal to 1 plus PV by RT. PV by RT is equal to Z. Z is what basically? Z is compressibility factor. How much compressible a gas is denoted by this factor. Now, if we plot this Z versus P, okay, so 1 would be our intercept, right? And our slope would be V by RT. Now, we can see the slope is directly proportional to B and B is our volume factor, correct? So, the gas having the greater volume will have a greater slope. Among neon, argon, xenon and krypton, which one has a greater volume? Xenon. So the slope for xenon will be maximum. So our answer would be option number A, xenon would be our correct answer. Correct? So moving on to the next question. It's just application based. If you can see, it's just application based. Consider the van der Waals constants A and B for the following gases. Which gas is expected to have the highest critical temperature? Now, before moving on to the question, we need to know that what is the relation for critical temperature. So, critical temperature Tc is given by 8A divided by 27 Rb. Now, if the equation is known to you, just do the calculations. For argon, Tc would be 8 into A is mentioned as 1.3 and it's mentioned as 1.3 divided by 27 into 8.314 gas constant into B is 3.2. Now on solving this, it comes out to be 0.014. Neon comes out to be Tc is equal to 8 into 0.2 by 27 into 8.314 into 1.7. This is effectively 0.004. Next is krypton. Krypton is 8 into 5.1 by 27 into 8.314 into 1.0, which is 1 basically, 0.18. And the last one is xenon. Tc is equal to 8 into 4.1 by 27 into 8.314 into 5. This is 0.02. So we have got the values. Now the highest critical temperature is shown by krypton. So your answer should be option number A. The next question says, there are plots given and the combination of plots which does not represent isothermal expansion of an ideal gas is basically. So, which the answer would be the plots which are given. First we need to see. One is P and 1 by Vm plot, which shows this one. P versus Vm plot shows this. Then you have PVM versus P showing this one, and U versus Vm showing this. Right? So how will we analyze? See, for isothermal expansion, we know from Boyle's law, P into Vm equal to constant. right? If that is the case, then we can say P is equal to constant by Vm. So if we plot P versus Vm, 1 by Vm, we will get a value of a slope but no intercept. So owing to that, this option is correct, option A. Again, PVM is equal to constant. So PVM value is always a constant. So this graph is correct. So the only incorrect ones would be B and D. How? See, it is saying that P versus Vm is being plotted. So this is inversely proportional to each other. So the graph should have ideally been this way. It is not so here. So this is not the correct representation, which is our answer, because the question says which does not represent the correct options. And with B, you have two options, B and C and B and D. Now C is correct, so we cannot plot that option or mark that option. So the correct option would be option number C, which says that the graphs B and D are incorrect, right? So this is how you have to eliminate the options. It is not necessary that you know all the correct options, or you can give justification for all the answers or all the options, but then you can obviously eliminate your answers, which is the correct approach to any question. The next question says, an open vessel at 27 degrees centigrade is heated until 2/5 of the air in it has escaped from the vessel. Assuming that the volume of vessel remains constant, the temperature at which the vessel has been heated. So the given temperature is whatever the values are given to you, first write down. The temperature given to us is, suppose T1, it is 27 degrees centigrade. So basically it is, every temperature should be calculated in Kelvin format and not in degree centigrade format, right? Now volume of the vessel is constant as mentioned. Pressure in the vessel is constant. It is mentioned, right? Now, volume of the air now has been said that when it is heated, 2/5 of the air has escaped. So if 2/5 of the air has escaped, then the remaining volume would be 1 minus 2/5, which should be 3/5, right? So supposing if the volume at temperature, initial temperature was, suppose V, then the final volume would be 3/5 of V, right? So what can we say? We can say, we could have said that volume into initial temperature 300 Kelvin is equal to reduced remaining volume into final temperature. Why have we used this equation? This is Charles' law equation. Whereas where we say that pressure is constant, and that is already mentioned in the question. So we can use the Charles' law. So V gets cancelled. 300 into 5 by 3 equal to T2. This should come out to be 500 Kelvin. So that is option number B. Okay. So when you write down the given values, the question becomes much more simpler. You can see what is asked and what is not asked. Alright. The next question says the volume of gas A is twice than that of gas B. The compressibility factor of A is thrice than that of B at same temperature. The pressure of the gases for equal number of moles is. So what is given? Given is the compressibility of factor of A is thrice of B. Compressibility factor of B. So compressibility factor is given as, we have just seen PV by RT we had written, but we'll write nRT here because we are not considering that there is only one mole. We are considering that there are significant number of moles. So for A we can write PA VA by NA RTA. Since the compressibility factors are given as the relation this one, so we can write 3 into PB VB by NB into RTB. Okay, It is also mentioned that VA equal to twice of VB. So substitute that PA into 2 VB by NA RTA equal to 3 into PB VB by NB RTB. There is another thing mentioned in the question that the number of moles and the temperature are same. So Na equal to Nb and Ta equal to Tb. Right? This is already mentioned. So just replace it. So I am replacing Ta equal to Tb and Na equal to Nb. Cancelling it out. VB gets cancelled. So PA by PB would be equal to 3 by 2. Or we can write 2 PA equal to 3 PB. That is option number B. Okay, moving on to the next question. A 10 milligram effervescent tablet containing sodium bicarbonate and oxalic acid releases 0.25 ml of carbon dioxide at temperature 298 Kelvin and pressure 1 bar. If molar volume of carbon dioxide is 25 liter under such condition, what is the percentage of sodium bicarbonate in each tablet? The molar mass of sodium bicarbonate is given to you. So how can we proceed? See what is there. That is sodium bicarbonate is reacting with oxalic acid. Right? So an effervescence is observed. That is obviously because of carbon dioxide. And you will get sodium oxalate and water. Right? Now, just balancing the equation, what would you get? 2 CO2, 2 NaHCO3. That's it. Okay. So, first things first, what is the number of moles of CO2 produced? How can we calculate? Produced. We can say that N would be equal to PV by RT because PV equal to nRT for an ideal gas. So, N would be PV by RT. Right? Now, let us calculate. So, pressure is mentioned as 1 bar, volume 0.25 into 10 to the power minus 3 liter. Why? Because it is mentioned in ml. Right? Okay. And then we have R would be 0.0821 into 298 Kelvin. Clear? So, this should be, upon calculation, you should get 1 into 10 to the power minus 5 mole. Okay, so this is done. Now, how would you calculate the number of moles of bicarbonate? It would be weight of bicarbonate. We have done it in class 11. Given weight by molecular weight. Okay. Now, given weight would be X and molecular weight is already mentioned 84. I think what was given 84 gram, right? So this is mentioned. Now number of moles of NaHCO3 we know. How do we know? See, number of moles of this thing we know. NaHCO3. How? See, in the initial reaction we are having 2 moles of NaHCO3 giving 2 moles of carbon dioxide. So it's a 1:1 ratio. So the number of moles of CO2 that we have obtained should be equal to the number of moles of bicarbonate as well. So from here we get X is equal to 84 into 10 to the power of minus 3 or minus 5 gram. Now we need to convert it into milligram because the given sample was in milligram, right? So how do we convert it? Into 10 cube. So this should come out to be 84 into 10 to the power minus 2 milligrams. So we can write it as 0.84 milligram. Correct? Now the percentage of NaHCO3 would be the amount of NaHCO3 that is actually obtained, that is the observed value by the given amount into 100. This should come out to be roughly around 8.4%. So this matches with your option A. Okay, clear? Moving on to the next question. 0.5 moles of A and X moles of B exert a pressure of 200 Pascal in a container of volume 10 meter cube at 1000 Kelvin. Given R is the gas constant, X is. So how can we do this? First of all, we have to see that the number of moles of A given is 0.5 and the number of moles of B given is X. Right? So the total number of moles would be Na plus Nb would be 0.5 plus X moles. Right? Now we know for ideal gas, PV equal to nRT. Now pressure is mentioned as 200 Pascal. Volume is mentioned as 10 meter cube. Number of moles is 0.5 plus X into R into temperature is 1000 Kelvin. Okay. Now solving this, we get 0.5 plus X would be equal to 200 into 10 by R into 1000. Cancelling it out, we are getting 2 by R. Correct? Now we can write 0.5 as what? Half plus X equal to 2 by R. So we can write X is equal to 2 by R minus half. So this should be 2R and 4 minus R. So X should be this much. This option is matching with option number B. That is what you get. X value. Clear? The last question for today's series is two closed bulbs of equal volume V containing an ideal gas at initial pressure Pi and temperature T1 are connected through a narrow tube of negligible volume. The temperature of one bulb is then raised to temperature T2. The final pressure is. So how do we do it? Okay. So let us consider that the initial number of moles, just a second. The initial number of moles in each container would be, initial moles is Ni is equal to Pi into volume by RT1. Okay. Total number of moles in both the containers would be, there are two closed bulbs, so total moles would be 2 into this PIV by RT1. Now after the mixing has happened, the number of moles left in the chamber would be, how many moles are left? That is final pressure into V by RT1. Right? This is in the left chamber. Okay? Because there are two chambers, and number of moles in the right chamber would be the same pressure PF into V by RT2. Clear? So the total number of moles would be left after the mixing would be PF into V by RT1 plus PF into V by RT2. This should come out to be PF into V by R into 1 by T1 plus 1 by T2. Right? Now, as total number of moles is a constant before and after mixing, whichever, so we can write it as 2 Pi into V by RT1 equal to PF into V by R T1 plus PF into V by RT2. So what can we write from here? V is common from both sides, so just cancel it out, and R is also common from both sides. So we can say PF is equal to 2 Pi into T2 by T1 plus T2. This should be our answer. Right? This matches option number B. So we come to the end of the series for states of matter. These are the different types of questions that I've discussed, and I've tried to keep in mind different categories of questions considering different concepts, so that all the types of probable questions that can come is discussed with all of you. So the only thing that you need to know is few formulas of critical temperature, most probable, average, speed, these kind of formulas, and just the basic concept of approaching a question. That is it. So in the next class or in the next video, we shall come up with another series, and some of the 10-year questions from the whole question papers, as in year-wise question papers, we might discuss, so that it becomes easier for your preparation. So keep practicing. Till then, take care and all the best.